We might need it in the future for the timekeeping of our award ceremonies. Anyway, we have now, last but not the least, our automotive category winners from the University of Bologna. So please welcome on stage the S Helmet team. So here is
This is Helmet, and it is a smart helmet with multi-sensor, and it is also self-sustainable because it harvests power from environmental sources. For example, there's a solar cell, and this is a kinetic generator, so it is powered by itself, and it has a multi-sensor network, for example an alcohol sensor to detect alcohol concentration in the biker's breath, and we have an LCD display in order to show data to the driver, and an eye blink sensor to detect drowsy driving conditions and to provide a feedback alarm to the user, and also accelerometer, light sensor and temperature sensor. So my teammates and I were sitting at the table and drinking beer and having talks, and we just thought, why don't we build a smart helmet with sensor and stuff like that? And then we had the opportunity to do it with the Texas Instruments Innovation Challenge, and we made it. The main reason we decided to build a helmet is for safety. That technology can help the human being and achieve more security and automation, and to have a better life for all the human beings in the world. Good afternoon. My teammates and I love motorcycles. I guess Cloven too. And but do you know that over 25,000 road fatalities are reported every year just in Europe? And do you know that actually most of them involve motorcycles? So we all love motorcycles, but we want to be safe, and that's why we designed Helmet. Helmet is a multi-sensor smart helmet designed to enhance human awareness driving on the road. And Helmet exploits both wearables and Internet of Things technologies. So we have data processing on board, multi-sensor network, and wireless interfaces. And I'm sure that you have already heard the word smart helmet somewhere else. By the way, Helmet is one of a kind because it is powered from environmental energy, and so we tested Helmet in real life, and this is a short demonstration of the device. seen in the video box with the Mauser logo. So thank you, Mauser, for your service, and thank you, Texas Instruments, as well for this opportunity. But now let's talk about features. The first feature is security. Shelmet embeds smart sensors, so the system can sense and take actions. Then we have infinite battery. Shelmet harvests energy from the environment, so we have a solar harvester and a kinetic harvester that continuously recharges the battery, so you don't have to charge batteries. And going on, we have the hands-free usage. You don't need to use hands to use Shelmet because of a speech recognition system, so you can keep the control of the bike. And last but not least, performance tracking. Shelmet can log and trace your skills, such as accelerations or steering angles, and so on. So let's have an overview of the concept. As you can see, the system is split in two different nodes. Both nodes are connected via Bluetooth, and the main node the helmet, it's on the helmet, and it embeds smart sensors, microphone, as well as LCD display. The second node, it's on the bike, and its main task is to acquire the infrared camera, reducing the computational effort on the first node. Plus, it is possible to connect it to the bike control unit and take actions on the bike itself. Finally, both nodes embeds an MSP432 microcontroller to process data on board, keeping a low power profile. Let's look at the sensors. The first sensor is alcohol sensor, and it is used to detect alcohol concentration in the biker's breath, and in this case the ignition of the bike will be prevented. Going on, we have the eye blink sensor, and it can sense the closure of the eye. This way it can be used as a gesture sensor as well as to detect drowsy driving conditions. In this case, the system will provide an audio feedback to the bikers in order to wake up him. Then we have the ambient sensors. The first one is the accelerometer, and it is used to detect IG forces due to crashes. And in this case, the system will automatically perform an automatic emergency call. Finally, there are the temperature sensors and light sensor, used to keep an eye on environmental parameters and also to automatically adjust the LCD backlight for power saving. Let's talk about the low power techniques used to achieve low power profile in Shelmet. The first one is that the helmet node architecture is split into independent subsystems. These subsystems have independent supply lines, so these lines are software selectable, and each subsystem is powered on only when it's truly needed. Going on, we have the wake-up radio system, and this way the device automatically switch off when you leave the bike, and then instantly switch on when you get back to the bike. But by the way, a low power profile is not enough to achieve self-sustainability. So we had to design an energy harvesting unit. The first part of this unit is the solar harvester, and solar energy is harvested by Shelmet from a tiny solar panel mounted on the top surface. And the core of the circuit is a TIIC battery manager state-of-the-art, which is the BQ25570. The overall efficiency is 90%, and the in-field measurement shows that the system can generate 45 milliwatts power at 50,000 lux. The second part is the kinetic harvester, and Shelmet harvests the kinetic energy from an electromagnetic microgenerator. And once again, we have a TI battery manager, which is the BQ25504. The overall efficiency is 80%, and we have 20 microwatts of average power generated. Now let's have a look at the final prototype for Chelmet. With respect for the helmet node, 3 boards have been designed and manufactured. The first one is also the main one, and it hosts an MSP432 microcontroller, as well as most of the sensors of the system. The second board it holds the LCD display, microphone and alcohol sensor. And the last one holds the tiny eye blink sensor that must be placed on the eye of the driver. Going on, we have a TI Bluetooth module, which is the CC2564. And finally, we have the solar panel, kinetic generator, wake-up antenna, and the battery. For the back node, we used an MSP432 launchpad, interfaced with a Bluetooth module, infrared camera, and wake-up radio transceiver. All of this stands inside a box manufactured using rapid prototyping technologies. And all of these have been tested in a typical application scenario. And the battery lifetime have been estimated with respect of these measurements. As you can see in the bar graph, using Chelmet 2 hours per day, the batteries are infinite. So the goal of self-sustainability has been achieved. Just think that we have been testing it for 5 months and we never charged the battery. But by the way, there are still room for improvement. So we have plans for Chelmet, and these plans are the employment of new energy sources, such as thermal energy, the implementation of an heads-up display using the new transparent screen technology, and the development of a smartphone app in order to enhance Chelmet connectivity. And then we are going to investigate for other context usage, such as motorsport or skiing. So, if you love motorbikes and you want to be safe, just come find us on www.chelmet.it. But now let me introduce my teammates, so Tommaso Polonelli and Lorenzo Spadaro, and our advising professor, Dr. Michele Magno. Thank you all for your attention.
Thank you. So we have a question.